Hi boys and girls, today we're going to make parachutes. Now I'd like you to think about what would happen if I would drop this piece of cardboard. I think everybody would agree that it would fall to the table, and that's because gravity always pulls things downward. Now what would happen if I would drop not only the cardboard but also this piece of folded up paper? Watch what happens. Okay. Gravity pulls them both to the ground. If I fold this a little bit smaller, it's the same piece of paper, looks very much the size of the cardboard. Let's hold them at the same heights and drop them. They hit the table at the same time. Now, what if I open it up and I drop them now at the same time and the same height? This took a little bit longer to reach the table. What if I open it all the way up? It's the same piece of paper, and I drop them at the same time from the same height. The paper took a lot longer to reach the table, and the reason behind that we can find in the air, because air is made of a lot of air particles, and just like if you were in a pool, you would have to push the water molecules away as you swim. Well, that's what this paper needed to do. It needed to push the air particles away. When it was folded up small, the same size as the cardboard, they hit the table at the same time. But as it got bigger, it had more air to push. So then it became slower in hitting the table. And then look, when I opened it really large, it took much longer to hit the table. And that's because it had a larger flat surface area, so it had more air to move. And because it had more air to move, we say it had more drag. Now, if you've ever been riding your bicycle, you can feel that resistance, that air resistance against you as you push it. As you ride your bicycle through the air, it feels like wind against you. And that's because you're pushing the air molecules apart to ride your bike. And you might think it's kind of a bummer to be slowed down and to have that air resistance. But it's kind of nice if you're trying to cushion a fall and fall slower. And that's what a parachute does. It adds more air resistance or more drag and allows the load to fall much slower. So this is how we're going to make our parachutes. You're going to use a grocery bag, and with the scissors you're going to cut off the handles. Okay, and you can kind of flatten the bag. We're going to cut one side over here. And then on the other side, we're going to cut the other side. And then we're going to open up our shape. And we sort of have a large rectangle. What you need is to make a square shape. So I'm going to use my ruler. And as you know, a square has 4 sides that are equal. So it looks like I can get 12-inch sides. You might want to use your ruler and draw a line. Okay. Okay, so we have our square plastic, and this is what you're going to use to carry the load, maybe a little person in here. You're going to make 4 holes in a cup with your hole puncher, and try and make them equal distance apart. So I am making my 2 holes directly across from each other. Then I'm going to the halfway mark between the 2 holes, punching another hole, and then turning to the other side and going halfway between the two original holes. So I have 4 holes about equal distance around the cup. Okay, then you're going to need 12-inch pieces of string or yarn. I just used a ribbon. We're going to need 4 of these, about 12 inches each. Okay, and then you're going to tie them into your cup. And you might need a little help with that. I did a double knot. Okay. And whatever you want to put in here, obviously you want it to have a cushioned fall. You want the fall to be slowed down from air resistance. And what's going to happen is the parachute is going to gather up and catch a lot of air particles, and that will slow down the descent or the fall. Okay, so I have put double knots in each string to hold the cup up. Then you have your square parachute, and you're going to take each corner and kind of just make a little bunch like that, and then tie your string or yarn around the end. And I am double knotting these also. Okay. Okay, so 2 sides are done. And we come to the other side of the cup and bunch it up a little bit, and then we're going to double knot this. And you might want to have a brother or sister hold the plastic bag for you because it's very slippery. One more double knot, and then one last side, 4 corners, and you probably remember the name for corners in math would be vertices. So the last vertex is going to be tied. And then one more double knot. Okay. Okay, so now I have my parachute, and you want to find a high place, a high area to launch this off of and to throw it down off of, and you're going to see that this cup is falling much slower. And the reason for that is because this parachute has a larger flat surface, and that larger flat surface is going to be pushing away more air. So it's going to have more air resistance, slowing it down, making the cup fall slower. And because it's pushing more air particles away because of all this surface area, that means it's going to have a lot more drag to it. So you could put a little toy in there and watch how the parachute slows it down. Now, I will tell you, it may not fall straight. It might fall kind of in a zigzag. And if you'd like to experiment after trying that a couple times, one thing you can do is cut a small, very small hole in the middle top of your parachute, because that will help it fall straighter. It won't swerve as much because that will just let a little air through there, because all this air resistance is making it fall a lot slower. It's creating a drag. Okay, so have a lot of fun with your parachutes.